For this example, we're told to solve the system of equations using any method. We have 4x minus 2y equals 6 and y equals 2x minus 3. This is set up perfectly for doing the substitution method. We already have one variable solved for, so we have y equals 2x minus 3. We can substitute that into the y in the top equation. So we'll have 4x minus 2 times the quantity 2x minus 3, and then all of that equals 6. Now our remaining equation only has one variable, so we'll try to solve for that variable. We have 4x minus 4x plus 6 is equal to 6. When trying to combine like terms, we end up losing the x variable. 4x minus 4x is 0. So we end up with the statement 6 equals 6, which is a true statement. So what that means is that there are infinitely many solutions to this system of equations. If we end up losing all of our variable terms and we end up with a true statement, then we know that we have infinitely many solutions. In fact, these represent the exact same line. And we can show that if we solve the top equation for y and write it in the same slope-intercept form. So if we did that, we have negative 2x is equal to negative 4x plus 6. So I'm subtracting 4x from both sides of the top equation. Then I'll divide both sides by negative 2. I'll end up with y equals positive 2x minus 3. So it wasn't obvious at first, but we can see that these are actually the same line. So where do they intersect? Well, they intersect everywhere, and that's why they have infinitely many solutions. If we didn't recognize that at first, doing the work of substitution and ending with a result that is true, losing all the variables, tells us our solution is infinitely many solutions. In this example, we again want to solve the system of equations using any method. Well, we already did the substitution method, so on this one, let's try elimination. We have 5y equals 3x plus 1, and 3x minus 5y equals negative 8. The bottom equation has all of the variable terms on the left, but the top one will need to subtract 3x from both sides. So now, that top equation is going to look like negative 3x plus 5y is equal to 1. So I'm looking at now this grouping of equations. I've rewritten the top equation down here. Well, in doing that, notice that I have the variable x terms with opposite coefficients, but I also have the y terms with opposite coefficients. So when I add these two equations together, I'm actually going to eliminate both variables. So the left side is going to leave me with just 0, but the right side is going to leave me with negative 7. And 0 doesn't equal negative 7. So we lost all the variable terms like in the last example, but we ended with a false statement. So because the statement is false, that means that there is no solution to this system of equations. So graphically, what's happening on this one is that these two lines are parallel to each other, so they're never going to intersect.